Good morning, students. Today concept particle theory of light as well as wave theory of light. This theory of light is also called as failure of wave theory. Here, what is the comparison between the particle theory of light as well as wave theory of light, or the failure of wave theory? Failure of wave theory means some reasons are there. Those reasons cannot be explained by using wave theory of the light. Means the wave theory is failure here. Some of the reasons are there. Some of the reasons, those reasons cannot be explained by using wave theory. What are those reasons? Getting? This concept is also called as failure of wave theory. Wave theory cannot explain some terms or some reasons why those reasons are happening. That is not explained by using wave theory. That's why this theory is called as a failure of wave theory. And what is the comparison between those reasons in between particle theory of light as well as wave theory of the light? As you know very well, what is the relation between energy of the radiation as well as, this is, I am talking about wave theory of the light first. According to wave theory, the first reason. For example, here, let us imagine this is the first radiation, this is the second radiation. I am going to merge these radiations. Then, after superposing or after merging these radiations, we are getting one of the big wave. Getting, this is the first radiation, second radiation. After merging these two radiations, I am getting only one radiation. Its energy is increasing. Getting, it is having some of the energy, it is having some energy. After merging as a one, its energy is increasing. Means its energy increasing means here I am taking as an intensity. Here one radiation, two radiation, then intensity is nothing but a number of waves. How to increase its intensity? Just you can take one more wave. Then its energy is increasing. Again, if you want to increase the energy of this radiation, again you have to increase the intensity. How to increase the intensity? Take one more wave. Then its energy increases. Or if you want to further increase its energy, again you have to increase the intensity of the radiation. Means how? You can take one more wave. Means by increasing the intensity, the energy of the radiation is increasing. This is according to what? Wave theory of the light. Means the energy of radiation can be increased by increasing the intensity of the light. Then what is the relation between intensity and energy of the radiation? That is directly proportional to each other. That is according to which theory? That is according to wave theory of light. Getting, according to wave theory of the light, the energy of radiation is directly proportional to intensity. Directly proportional to intensity of incident radiation. Intensity of incident radiation. This is according to what? This is according to wave theory of light. This is the reason. In order to increase the energy of the radiation, we have to increase the intensity. That's why the relation between the energy and the intensity is directly proportional to each other. According to this theory, this is according to wave theory. But according to particle theory, what is happening? But according to particle theory in the sense, you can imagine the example as photoelectric effect. According to particle theory, it is not happening. Getting, let us consider this is a metal, these are the electrons. I am using one radiation here. Getting, its intensity is equal to I1. The electron is emitting. Its energy is equal to, just you can imagine, this is 1 joule. This electron, emitted electron having, the energy is equal to 1 joule. Next, I am increasing the intensity. This is I2. I am increasing the intensity. Again, the electron is emitting, but the emitted electron is the energy is equal to 1 joule. In this case, the photoelectric effect is the evidence for particle theory. It is supporting particle theory. But in the photoelectric experiment, if you increase the intensity of the light, the emitted electron is having the energy. That energy is not increasing. Whatever it is the intensity of the light you are going to increases, the energy of the emitted electron is not changing. It is a constant. That's why this emitted electron is not depending upon by changing the intensity of the light. That's why if you increase or decrease the intensity of the light, by increasing the intensity of the light, the energy of the photo emitted electron is not changing. But according to the wave theory, if you increase the intensity, the energy of the light goes on increases. If you increases further the intensity, the energy of this light is again increases. But according to wave theory, the intensity is directly proportional to the energy of the light. But according to particle theory, the intensity and energy, they are independent with each other. That's why, what is the reason behind this one? Why it is happening so? That reason why it is happening. But according to wave theory, intensity depending upon energy of the light is depending upon intensity. But according to particle theory, the emitted electron or the energy of the emitting electron is not depending upon the intensity. What is the reason behind this one? That reason cannot be explained by the wave theory. Or why it is happening so? That reason, the wave theory, it cannot explain. That is, this is a failure of wave theory. According to particle theory of the light, means in photoelectric experiment, the energy of the light, the energy of the, not light, the energy of photo emitted electron, photoelectrons is not depends. Means the energy of the photoelectron is not depends on intensity of incident radiation. This is the first failure of wave theory. In the photoelectric experiment, how come this intensity is not changing the energy of the photoemitting electrons? Why it is so happening? That reason cannot be explained by the wave theory. This is the first failure of wave theory. And what is the second failure of wave theory? That is, according to wave theory, the concept of wavefront, by using wavefront. What is wavefront? Let us consider it is wavefront. What do you mean by wavefront? Here I am taking, this is the radiation, this is the second radiation, this is the third radiation, this is the fourth radiation. Here all together I am going to call it as the beam of radiation. The sets of radiation we are going to call it as getting the beam of radiation. I am considered this point, and this point and this point. This region of light is called as wavefront. Getting this point, this point, this point, this point. This plane of the light wave. Getting this plane is called as wavefront. Number of waves are there. Number of first radiation, second, third, fourth. I am taking this point, I am taking this point, I am taking this point, I am taking this point. And this region together is called as a wavefront. Or else this point, this point, this point, this point. This region together we are going to call it as wavefront. Getting, let us consider according to wave theory. By using wavefront means the number of radiations they are coming. According to wave theory, by using the concept of wavefront, when wavefront is incident on metal surface, there should be a ejection of number of electrons, number of electrons simultaneously. It means that wave theory is explaining, or wave theory is telling that this is the metal surface, it is having number of electrons. Whenever the wavefront or beam of radiation is incident on the metal surface, number of electrons has to be ejected from the metal surface. This is according to which theory? Wave theory. For example, whenever the wavefront is incident on the metal surface, wave theory is telling that maximum number of electrons that are emitting simultaneously from the metal surface. This is according to which theory? This is according to wave theory. But according to particle theory, what is happening? Particle theory means I am using photoelectric effect here. But according to particle theory, let us consider these are the number of electrons. If you use the wavefront and number of radiation or beam of radiations which are incident on the metal surface, only one electron is emitting. For one radiation, one electron is emitting. For second radiation, again one more electron is emitting. For third radiation, again one more electron is emitting. But particle theory, what it is telling? One radiation emitting one electron from the metal surface. Getting? In order to emit the another electron, another radiation is required. In order to emit the another electron from the metal surface, another radiation should be required. But in which experiment that is? According to particle theory of light, it means in photoelectric effect. But in photoelectric effect or according to particle theory of light, it is not happening. It is not happening. It is not happening in the meaning, whatever it is the explanation given by the wave theory of light, that wave theory what it is telling, that is not happening in the photoelectric effect. Wave theory what it is telling, when the wavefront it is hitting the metal surface, then suddenly there is a ejection of number of electrons from the metal surface simultaneously. This is explaining by which theory? Wave theory of the light. Means let us consider it is a metal. Whenever the wavefront is hitting, means beam of the radiation whenever it is hitting the metal surface, suddenly there is ejection of number of electrons from the metal surface. This is explaining by which theory? That is wave theory of light. This is the reason telling by the wave theory of the light. But particle theory or in photoelectric effect, what is happening? One radiation, one electron. One radiation, one electron. One more radiation, one electron. One radiation is required to emit one electron simultaneously. But what is the reason? What the wave theory explain? We are not getting according to wave theory in particle theory. Whatever is the explanation given by the wave theory, we are not getting the same as in photoelectric effect. Means according to particle theory. Why it is so happening? What is the reason behind this one? But in this case also, one radiation emitting one electron, another radiation emitting another electron. This is why it is happening so. Why the number of electrons they are not emitting simultaneously from the metal surface in photoelectric experiment? That cannot be explained by wave theory of light here. Again in the second reason also, this is the failure of wave theory. Getting? And what is the third observation here? What is the third reason that cannot be explained by the wave theory? That is according to wave theory of light. According to wave theory of light, there should be a time lag in between incidence of radiation and just can imagine here. What is the wave theory? Let us consider. These are the light radiation. This is first, this is second. Suddenly, these radiations are merged with each other and became the big wave. Getting? This is the resultant wave. This is only one wave. These two waves are combined with each other and become the big wave here. And what is according to wave theory of light? This radiation and this radiation suddenly they merged with each other and became the big wave. But these two radiations they combined and became the big wave. In this process, there is a time lag is there. In order to become the big wave, it will take around 1 second, 2 seconds, or 10 seconds. For example, like there is a time lag is there. Here, this wave and this wave they combine with each other to become a big wave. There is this process will take some time there. That's why, according to wave theory, the wave theory is explaining that there should be a time lag in between this process, or else you can take this also. The wave theory explaining that this is the metal, these are the electrons. The light is incident on the metal surface, and the electron is emitting from the metal surface here. First, light has to be incident. After its energy is transferred to electron. By receiving that photon energy, the electron is emitting from the metal surface. And this incident and this ejection of electron, there is a time difference is there. For example, the time instant at which this radiation is incident on the metal surface is 1 second. The electron is coming out of the metal surface is 3 seconds. What is the time difference between incidence and ejection of the electron? That is 3 minus 1 is 2 seconds. In order to emit the electron from the material, what is the time difference is there? Whenever the light is incident, after 2 seconds the electron is emitting. This is the reason explaining by which theory? This is the reason explaining by wave theory of the light. What is the wave theory of the light? First, radiation has to be incident. After its energy is getting transferred to the electron, getting after 2 seconds the electron is emitting. Means there is a time lag is there. Time difference is there in between incidence of radiation and ejection of electron. This is according to which theory? This is according to wave theory of the light. This is according to wave theory of the light. But according to particle theory. But according to particle theory, means in photoelectric experiment. According to particle theory, there is no time lag. There is no time lag between incidence of radiation and ejection of electrons. Ejection of electron from material surface. From material surface. Here, according to wave theory of the light, there is a time lag between incidence and ejection. Wave theory telling after incidence, for example, when the light is incident on the metal surface, the time is 1 second. After 2 seconds, for example, the electron is emitting. Means there is a time difference is there. This process will take some time. Getting? This is according to wave theory, but according to particle theory. The particle theory in the sense photoelectric effect here, there is no time lag in between the ejection of the electron as well as the incidence. The particle theory telling that suddenly incidence of radiation, there exists suddenly there is an ejection of electron. Whenever the light is incident, suddenly there is an ejection of electron. Means there is no time lag in between ejection of electron as well as the incidence here. But according to wave theory, there is a time lag between incidence and ejection. But according to particle theory, sudden incidence is sudden ejection. Means there is no time lag in between incidence as well as ejection of the electron. This is according to which theory? This is according to particle theory. And last one more reason is there. That is the fourth reason. That one, the fourth failure of wave theory. And in the third reason, why it is so happening, why there is no time lag in between incidence and ejection, that reason cannot be explained by wave theory. Again, this is also failure of which theory? Wave theory. And next, fourth one, there is no explanation. There is no explanation about threshold frequency. About threshold frequency by which theory? Wave theory. This is by wave theory. Let us consider regarding the threshold frequency, the wave theory is cannot explain. But according to particle theory, for example, according to photoelectric effect of particle theory, in order to emit the electron from the surface of the metal, this radiation, it has a certain frequency. For example, this radiation is having a low frequency, then there is no emission of the electron from the metal surface, means there is no photoelectric effect. But in order to emit the produce a photoelectric effect, this radiation, it has a minimum frequency or suitable frequency. That frequency of radiation we are going to call it as threshold frequency. In order to produce a photoelectric effect, this is according to particle theory. In order to emit the electron from the material, this radiation has a threshold frequency. It has a minimum frequency, getting a suitable frequency. In the sense, if its frequency is very low, then electron is not emitting from the material. Means there is no photoelectric effect. In order to produce or in order to emit the electron from the material surface, this radiation, it has a minimum frequency. That minimum frequency we are going to call it as threshold frequency. Getting threshold frequency. This is according to which theory? This is according to particle theory. But according to wave theory, there is no concept of threshold frequency. The wave theory cannot explain, wave theory cannot talk about this term. Getting the wave theory, according to wave theory, for example, this is the first radiation, this is the second radiation. After, in order to merge and become the big wave, the energy of the frequency of these waves is cannot considered. Its frequency is lowest, this frequency is lowest, but it is possible to make the big wave. Getting this light having very lowest frequency, this light having very lowest frequency, but in order to produce a big wave, or in order to take a combination of the wave, in order to produce a big wave, getting these radiation is need not to be have a maximum frequency. It is lowest, but still they are combining and become the big wave. This is according to which theory? This is according to wave theory. But in according to particle theory, getting if its frequency is very lowest, you are not getting the electron out from the metal surface. There is no photoelectric effect. In order to produce a photoelectric effect, this light must and should have a lowest frequency. That is minimum frequency, suitable frequency. If its frequency is very lowest, it is impossible to take the electron from the metal surface. That's why here the threshold, the concept of threshold frequency we are studying in which theory? Particle theory. But according to wave theory, we are not talking about this term only, because in order to produce a big wave, this is lowest frequency, it is also having lowest frequency, but still there is a superposition of these two waves and produce a bigger wave. Means according to wave theory, or the wave theory is not talking about the threshold frequency, but according to particle theory of light and photoelectric experiment, there is an important term getting, that is a threshold frequency. That's why it is so happening. Why threshold frequency is required to produce a photoelectric effect. Getting that reason cannot explain by wave theory of the light. Getting these are the four reasons. Those reasons cannot explain by the wave theory of the light. That's why the concept or title of this concept is failure of wave theory. These four reasons cannot explain by using wave theory of the light. That is the first one. First one, the relation between intensity of incident radiation as well as energy of the radiation is directly proportional to the according to which theory? That is according to wave theory of the light. But in the photoelectric experiment, but according to particle theory of the light, the energy of the photoemitted electron is not depending upon the intensity of the radiation. Why it is so happening? By increasing the intensity, emitted electrons, its kinetic energy increases. In which theory? This is according to wave theory. But according to particle theory, the emitted electron, its energy is not depending upon the intensity. That's why this is the first failure of wave theory. That reason cannot be explained by using the wave theory. And what is the second one? Second one, according to wave theory, whenever the wavefront is hitting the metal surface, the wave theory is telling that number of the electrons are emitting from the material surface simultaneously. This is according to which theory? Wave theory. But in photoelectric experiment or according to particle theory, it is not happening. That reason is also not explained by using wave theory. That is also failure of wave theory. And what is the third one? According to wave theory of the light, there should be a time lag is there. Getting for example, in order to, this is the incidence. After some time, the electron is emitting. There is a time lag in between incidence as well as rejection. This is according to which theory? This is according to wave theory. But according to particle theory, there is no